Thank you, Annette, for that lovely haiku. It might be taking your sushi roll. It's a possibility, but we're hoping that that won't happen. This is what I have so far of the first chapter of my thesis, and I've been working on it in collaboration with folks from the Bren School, as well as Conservation International, MLab, and the Nature Conservancy. As some of you may know, there is an existing international goal called 30 by 30, in which over 200 countries have committed to protecting 30% of the world's natural spaces by the year 2030. In the ocean, only 3% is currently fully or highly protected. Moving forward, it is important to figure out which parts of the ocean are most useful to protect, especially given a rapidly changing climate. We know that MPAs support biodiversity, and there's evidence that shows that biodiversity could foster ecosystem resilience. However, it is an open question as to which ecological mechanisms may be at play in ecosystem resilience, specifically with regards to climate change. So we set out to answer the question, can MPA features counter the ecological effects of climate change? To do this, we first developed a framework of the ecological effects of climate change. The physical effects of climate change are increases in temperature and acidity. But since MPAs don't act directly on those features, we wanted to look at the ecosystem effect, which through a literature review, we found are shifts in phenology, habitat availability, species range, nutrition, reproduction, disease and parasitism, and calcification. We also wanted to do an overview of what MPAs can and cannot do. They cannot act directly on temperature or pH. And from this perspective, one may think that MPAs have no effect on climate change. However, MPAs do stop extraction and habitat destruction. And in doing so, they can indirectly support populations and ecosystems in a way that buffers the effects of climate change. Our goal for this project was to figure out in what situations that applies. And to do this, we first developed a framework of the MPA effects that are relevant to climate change. And based on a literature review guided by key reports and papers, we found 5 overarching categories. First, direct effects, in which the MPA stops the climate effect directly. We weren't expecting to find evidence of this, and also did not find evidence of this, but wanted to include it in our categorization just for the sake of a thorough literature review. The second is population, in which the MPA offsets mortality of protected populations. There's positive ecosystem effects, in which the MPA supports a more resilient ecosystem structure. Negative ecosystem effects, in which the ecosystem in the MPA does worse than the ecosystem outside, and no effects. We used a Web of Science search to explore examples in the existing research, and our keyword search resulted in 933 papers. After manual filtering, we narrowed to 49 relevant papers, which were filtered for papers that were empirical, studied climate change, and also explicitly looked at the effect of the MPA. This is the general global distribution of the case studies that we found. It's fairly evenly distributed. There's very few studies at the poles, which makes sense because there aren't MPAs there. A lot of studies are disproportionately around Australia and the Northeastern Pacific. And we also found almost no studies in South America and Africa, which is, we think, possibly a gap from having a global review that was conducted exclusively in English. These are the different habitat types that were represented in our global review. Coral reefs are the most common habitat type represented, which makes sense because coral reefs are often the protected habitat by an MPA, followed by rocky reefs. The triangle that says NAs are case studies that looked at species rather than a habitat as a whole. This is a representation of the types of the distribution of MPA effects that we found in our case studies. The most common MPA effects were positive ecosystem effects, in which the MPA supported a more resilient ecosystem. and no effects, where the ecosystem in the MPA and the ecosystem outside of the MPA responded the same to a climate event. The second most common effects are population effects and negative ecosystem effects. You'll notice that I started with 5 categories and now I'm only showing 4, and that's because the 5th category are direct effects, and we didn't find any evidence of direct effects. This bar plot shows the climate effects associated with each of our marine MPA effects. Overall, it seems that the representation of the different climate effects that MPAs can act on is pretty even across the board of the MPA effects that we looked at. The most common one being habitat availability. The least common are reproduction and phenology. I also wanted to go into case studies to kind of in more detail explain what I mean by each of the MPA effects. So our first case study is an example of a population effect, which was published in 2023. Researchers surveyed 52 rocky reef sites over 3,300 kilometers in the Mediterranean Sea, and they recorded biomass at each of the sites. They found that biomass decreased with temperature at the same rate across the board, but the biomass in the MPAs remained higher after the heat wave. So we designated this as a population effect because the MPA offset mortality of the population within the MPA. Our second case study is an example of a positive ecosystem effect. This was published in 2020, and researchers compared urchin predator populations inside and outside of the Channel Islands marine protected area in California. An important part of this is that there was a sea star die-off that coincided with the 2014 marine heat wave, and sea stars are really critical urchin predators. Inside the MPA, researchers found more and larger alternate urchin predators besides the sea star, and did not find that outside of the MPA. And so in this example, the kelp forest persisted at a higher rate inside the MPA, and this is an example of the MPA fostering a more resilient ecosystem. Our third case study is an example of a negative ecosystem effect. Researchers collected samples of Acropora formosa, which is a type of coral, in an MPA in Nha Trang Bay, Vietnam, as well as a polluted fish farm near the MPA. They took the samples back to the lab and compared them, exposed them to herbicide at ambient and elevated temperatures. They found that the corals from the protected area actually started bleaching even before the treatment started. And they found that the samples from the protected area have more stress-sensitive symbionts, while the samples from the fish farm have stress-resilient symbionts. And so in this example, the MPA actually supported a less resilient ecosystem, which is why this is an example of a negative effect. Lastly, this is our case study of no effects. And this is from a 2021 paper in the Philippines. Researchers monitored two MPAs around the Philippines in Apo and Sumalan Islands. And they monitored reef fish structure and benthic cover inside and outside of those MPAs. They found that fishing-induced biomass change did not affect hard coral cover, but hard coral cover significantly affected 11 out of 13 trophic components. An important part of this paper is that coral mortality is strongly associated with climate change. And since the researchers found that coral mortality is associated with climate change, and coral was such an important driver of the trophic structure, the stopping fishing, which is what the MPA did, could not overcome the effect of climate change, which was the coral bleaching. And yeah, okay. So my conclusions are that when specifically examining resilience to climate change, the effectiveness of marine protected areas is variable. It depends highly upon which species benefit most from protection and how important those are to ecosystem structure. We found no examples of direct effects of MPAs. So in no scenarios that we found do MPAs directly stop temperature increase or acidity increase. And we also note the limitations of doing the study in English when we're doing a global review. Thank you very much.